problem number 1, we're asked to do several things. First of all, to tell if the parabola goes up or down. Next, to find the vertex. Then to find the equation of the line of symmetry, to find the y-intercept, and finally to graph it and to complete the table. So let's first of all identify whether the parabola goes up or down. So the A. So looking at x squared plus 5x plus 6, we see that the A, because we know in general that the function ax squared plus bx plus c, which is a quadratic equation in standard form, the A, if it's positive, the parabola goes up. Well, our A here, even though we don't see a number, is 1. So for A, parabola goes up. Okay? B, we need to find the vertex. Well, in order to find the vertex, we need to find the coordinates, which we indicate are h comma k. H is found by using the formula negative b over 2a. Our b in this case is 5, so we go negative 5 over 2a, which is 2 times 1. So we get negative 2.5 as our h. And then to find k, we simply input negative 2.5 in for the x in the expression. So we would go negative 2.5 squared plus 5 times negative 2.5 plus 6. And then looking at simplifying that expression, let's quickly go to our calculator here. Okay, so if I go, I guess I'm going to have to push this up in order to get the calculator. Let's see, negative 2.5 squared, helps if I put that in the correct number, 2.5 squared plus 5 times negative 2.5 plus 6, we get an answer of negative 1/4, or negative 0.25. Negative 0.25. So we find out our k is equal to negative 0.25. Alright, so when I'm filling out so that's my vertex then. Vertex is, so my vertex is negative 2.5 comma negative 0.25. Alright, and then we're asked to find the equation of the line of symmetry. Well, if I go ahead now and look at the x-coordinate of the vertex, that is my equation of the line of symmetry. So C then would be x equals negative 2.5. And then I need to find the y-intercept, and which is D, and that's my C in the quadratic. So in this case, my y-intercept is equal to 6. Alright? So when I'm filling out the table, basically what I'm going to do is I'm going to use the x-coordinate of the vertex as my middle point. So I'm going negative 2.5. And then I'm going to go to the left and to the right. So I'd go negative 3, negative 4. And then I'm going to go negative 2, negative 1. Those will give me values on both sides of the vertex, so I'll be able to adequately go ahead and graph this in a couple different ways. One way I have found is simply I like to use a table, which makes it a little easier to do. So I can take those, I can go stat, edit, and I can input those figures on in L1 for my x coordinate. So I'd go -4, -3, -2.5, -2, -1, and then I can go ahead and highlighting the heading of L2, I can type in the expression, the quadratic expression, using L1 as my x. So in other words, I would go second one, which gives me L1. I'd go L1 squared plus 5 times L1 plus 6, and hit enter, and that will generate the y values, the f of x values, the function values for those they'll generate the y values for the x inputs. So at -4 I'm going to put 2, at -3 I'll put 0, at -2.5, of course we already know that's -0.25, at -2 it's 0, and at -1 it's 2. So let's write those in. So I have 2, 0, 2, 0, -0.25, 0, and 2. So I would fill my table in, just like I have here, and then I can go ahead and graph that. Okay, and so my graph is going to look similar to this. Okay, x squared plus 5x plus 6. Okay, now the question is, sometimes you don't find out, how can you find out the zeros if it doesn't show up on the table? So you're looking here. The zeros again are these points where the graph crosses the x-axis. So you know here we have -3 and -2. Okay, there is my at -2.5. There's my line of symmetry. So you can see at -2.5, there's where the vertex is, and the y-coordinate is about -1/4. Now sometimes you're going to have to guesstimate where those zeros are at. So based on your graph, you would give an approximation as to where the zeros occur. Again, a 0 is when the value of the function, the y, is 0. What are the x values? Okay, so that would be my answer at this point in time. We are going to come across in the following sections how to be more specific and actually algebraically find out exactly where those zeros are.